Everybody, welcome to Studio 64. My name's David. I've been searching the interzones for some more science, space, and tech news to share with you, and I came across this over at Science Alert. Yes, strange radio signals from deep space baffles scientists. Well, I'm sure it would. Wow, okay. We've received a strange signal from across the galaxy, and astronomers are struggling to understand what it means. It's probably humans not interested. Yes, we're a little bit like that with our galactic neighbours, I guess. All they got to do is intercept some of our Wi-Fi signals or a Netflix special, and they wouldn't want to come anywhere near us. They know what's emitting the signals. It's a neutron star named ASKAP J193505.1 plus 214841.0 ASCAP 1935 plus 2148 for short. That's actually quite funny. Located in the plane of the Milky Way, some 15,820 light years from Earth. But the signals themselves are like none we've ever seen before. The star goes through periods of strong pulses, periods of weak pulses, and periods of no pulses at all. Now, what we don't know, according to a team led by astrophysicist Manisha Caleb of the University of Sydney in Australia, is why. The strange object poses a fascinating challenge to our models of neutron star evolution, which, let's be honest, are currently pretty far from complete. As usual, I'll leave the link to the main article below the video, so you can pop in, check out the embedded links, go for a bit of a deeper dive, beyond the main article if you want to. It makes it a very interesting read, believe me. A neutron star is what's left after a star within a certain mass range dies, between about 8 and 30 times the mass of the sun. The star's outer material, excuse my mouse clicky finger, it seems to be operating on half a Biden today. The star's outer material is blasted off into space, culminating in a supernova explosion. The leftover core of the star collapses under gravity, forming an ultra-dense object up to 2.3 times the mass of the sun in a sphere just 20 kilometers or 12 miles across. Gee, that's incredible. Again, I'm not a scientist, astrophysicist, astronomer. Anyone knows more about it, please let us know down in the comments. We'd love to hear from you. It'd be awesome. Thank you. The neutron star that results can then present in a variety of ways. There's the base neutron star, which just hangs out, not doing a great deal. There's the pulsar, which sweeps beams of radio emissions from its poles as it rotates, flashing like a cosmic lighthouse. Then there's the magnetar. This is one I didn't know a lot about. A neutron star with an extremely powerful magnetic field, which jerks and erupts as the outward pull of the magnetic field wars with the gravity, keeping the star together. Okay, cool. There can also be some crossover between the neutron star types, suggesting they may be different stages of neutron star evolution. Generally, however, pulsars, magnetars, and neutron stars tend to behave in relatively predictable ways. Now, ASCAP J1935 plus 2148 does not behave in ways that are normal for a neutron star of any established kind. It was first identified serendipitously during observations of a different target, and follow-up observations were made using the Australian Square Kilometre Array Pathfinder, or ASCAP, and the Meerkat radio telescope in South Africa. Yes, the researchers also dove into previous ASCAP observations covering the same patch of sky. They found that ASCAP J1935 plus 2148 has a regular period of pulses of 53.8 minutes, but that seemed to be the only normal thing about its pulsations. On pulsation mode, they found it was extremely bright with highly linear polarizations, but then it would subside completely with no measurable pulsations at all for a period. Seems a little bit odd, doesn't it, if they're, very regular normally. Whether they're active or inactive, if you know what I mean. This one seems to be all over the place. Finally, the star was detected resuming its pulsation activity, but a whopping 26 times fainter than its earlier bright mode, with light that is circularly polarized. Now, in recent years, several strange objects have been found spitting out repeating signals in the southern sky. Although they don't all behave the same way, they could be related. Now, Gleam XJ162759.5 9.5-52304.3 is an object near the galactic center. that was caught spitting out bizarrely bright flashes for just 3 months before falling quiet again. GPM J1839-10 was found to behave like a bizarrely slow pulsar, emitting 5-minute bursts of radio waves every 22 minutes. And GCRT J1745-3009 is a pulsing object near the galactic center with a period of 77 minutes. Now, we don't know for a certainty what any of these objects are, but neutron stars seem likely. An ASCAP J1935 plus 248 Caleb and her colleagues suggest, could be a sort of bridge between the different states. Interesting. The differences between its pulsation modes are likely connected to magnospheric changes and processes, suggesting that all the objects belong to a new class of magnetars, possibly as they evolve into pulsars. ASCAP J1935 plus 2148 is probably part of an older population of magnetars with long spin periods and low X-ray luminosities, but magnetized enough to be able to produce coherent radio emission, the researchers write in their paper. That's interesting. It is important that we probe this hitherto unexplored region of the neutron star parameter space to get a complete picture of the evolution of neutron stars, and this may be an important source to do so. Yes, the findings have been published in Nature Astronomy. Yes, check Nature Astronomy out. It's very interesting. Love having a good read of that every so often. So there it is. Yeah, very, very strange behavior from neutron stars. Interesting. All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News update. If you enjoyed this video, please like, share, subscribe. I'd greatly appreciate it. If you're up for it, drop a comment down below the video. I'd love to hear what you think. All right, take care, and as I always say, if you can't be good at it. And as I also always say,
a most fascinating thing happened.